You are at the supermarket in line to pay. As always, your queue is the slowest of all and then you decide to change. Error. Now your new row seems the slowest and what's worse, the queue you were in before seems to be moving forward like lightning. Desperation. Will mathematics be able to help us in these fundamental problems? Don't worry, the math is always there. Today in deriving, queuing theory. The queuing theory is a very important mathematical theory used in multiple applications such as computers, telecommunications, engineering or to model supermarket queues, those of highways or airports. This theory models queues and service providers and its fundamental objective is to predict queue lengths and waiting times. These models are then used to optimize the system, so that waiting times are reduced and people are happy in a world of joy. The queuing theory uses many methods of statistics and probability theory, and his main tool is Markov chains, a full-fledged hipster. A Markov chain is a stochastic process, that is, a random process that varies over time, such as the stock market, the climate or the world population. Markov chains are characterized as processes that have no memory of the past. In other words, the probability of something happening depends only on the current state of the system. We forget about what happened before. Take, for example, this diagram of a Markov chain. The probability that, if one day it is sunny the next day too, is 0.8, and that it rains is 0.2. And that is regardless of whether there have been 3 consecutive days of sunshine or we have been rainy for 3 months and the sun has just risen. What means that a Markov chain is something like a maze in which at each fork you choose the path at random, and the probability of choosing one or the other doesn't remember if you've been there before. As you can see, Markov chains are not suitable for labyrinths, but they are suitable for rows. In principle, what it will take a person to pay in his turn in the supermarket queue does not depend on whether the previous ones have taken a long time or a little, whether they were ladies or gentlemen, whether the checkout has been open for 10 minutes or an hour. Well, and from all those very clever studies about rows and queues and stochastic processes, are there any conclusions that can be useful for our everyday life? As it turns out, yes. So take note that your life is going to be simplified. Situation in the supermarket. You arrive and there are 2 rows, one with many carts but carrying few things each, and another with few carts but very full. Which one do you choose? Your life may depend on this moment. Common sense and math, with Markov at the head. They tell you to choose the line with few cars, even if they are very full. Why? Because within the process of going through the checkout, the part that can go wrong or take longer is the time to pay. The coins fall. I do not carry change, the card does not work, therefore it is best to go to the line where that moment will happen less often. The part of passing the goods in principle is safer and takes less. Okay, you're already in line and you see that the others are going faster, do you change or not? Well, here Markov is clear. It doesn't matter exactly. If there are n rows of the same characteristics, for example, in the toll of a motorway, the probability that you are on the slowest one is 1 in n, and if you change yourself, the probability that the new one will be the slowest is exactly the same, because this process does not save memory of the past. Is it always good to put an extra lane to improve traffic? Well, surprisingly, no. And this is known as the Breas paradox, which says that sometimes adding a new lane makes the situation worse, makes traffic go slower, even if the number of cars is the same. This is so incredible is equivalent to saying that in some cases eliminating a lane would improve the traffic situation. Unbelievable. That's why it's called a paradox. Incredible, but true, it has already happened in the traffic of cities like Seoul, Stuttgart or New York. You have to study the situation well before making these types of decisions. And can nothing ever be done to improve the situation? Yes, you can. If there are n suppliers, n cashiers in the supermarket, n security posts at the airport, it is best to stand in a single line and distribute people at the stalls upon arrival. All problems and delays are distributed equally among all posts and the overall waiting time is reduced by a factor of n. This is done by some supermarkets and almost all airports. If they didn't, security and immigration controls would be much slower and more chaotic. People who work in queue theory make internet traffic smoother, roads work better, we suffer less in supermarkets, and factories are better designed. Anyway, if you don't want to wait too long in line, pay attention to mathematics. Although sometimes beautiful things can happen waiting in a line, you can win some Clash Royale battles, you can meet the love of your life, or better yet, you can keep watching deriving videos. See you in the queues.